I can. Okay. Yep. All right. What's that word? Exponential, right? Linear. What's that mean? Line. So what we're talking about is something like this versus something like that, right? Exponential growth means something grows a lot faster, and it actually usually means you're multiplying over and over again, right? Times 2 or times 3 or something like that. If it's linear, what are you doing over and over again? Yeah, so constant rate, that means like you're adding 2, right? Or if it's going down, you could be subtracting 2 or plus 4 or minus 7 each time, right? Something like that. Exponential growth could also be this way. That actually be called exponential decay, right? You've heard that probably before in science, talking about half-life and stuff like that, where we could be multiplying by a half. Things like that. When you talk about the growth of money, over time, you're talking about exponential growth. All right, so we have to determine which one is this table. Is it linear, exponential, or neither? All right, here we go. So when we go up by 7 here on the x-axis, we go over 7. What happens to the y? It went up by 5. Okay. And then when we go up 7 again, what happens? Multiplies by 5, right? Okay, so let's rethink the first one. Was the first one times 5? Also? No, it was times what? Okay. And then from here to here, it's times what? Are they multiplying by the same number over and over again? No. So that means it's not linear because they're not adding the same. And it's not exponential because they're not multiplying by the same. So it would be neither in this case. They're multiplying by different numbers each time. Okay, let's do another one. This is increasing by 3s. So that's all the same. That's what we want. That way we can compare. All right, what's happening here? Yeah, probably up 7. All right, is this one also up 7? Is this one also up 7? So they're adding 7 each time. That means it's linear. Yeah. All right. Here we can see that this is increasing by 7 each time, right? This one up 4, but this one's up 8 and this one's up 16. Is that really the pattern? What are they doing? Right. So times 2, times 2, times 2. All right, let's do another assignment here. That's right. Exponential growth means you're multiplying over and over again. All right, the table represents the number of milkshakes sold by a restaurant since they were added to the menu. Which graph best represents the relationship between time and the number of milkshakes sold? All right, what's happening? Well, they're talking about every 3 months, so that's good. That's what we're talking about. We want that same rate of time each time that we can compare. All right, what's happening here and here? Are they adding or multiplying by something? It looks like they're adding the same each time or about the same. It doesn't have to be perfect here. All right, this is a real life model. Models aren't perfect. So this is up by about 120. Right? If you think of this as 260 instead of 259, okay? This one, isn't that up by about another 120? 380 to 500, and then so on down the line. So since it's increasing by 120, that's linear. That's a linear model. Linear models are lines, not curves like this. Okay. Let's do another one of those. .5 to 19.3 to 100. Are they adding the same number each time? No. Right? They're multiplying by something. It looks like by about, what, 6 or so? Ish. Okay. It's an exponential growth. All right, that's easy enough. Let's do another one. I think I had 4 for today. Really? They all. Okay. Moore's law says that the number of transistors in a dense integrated circuit increases by 41% every year. That's a lot, by the way. In 1974, a dense integrated circuit was produced with 5,000 transistors. Okay, it's 74. Which expression gives the number of transistors in a dense integrated circuit in 1979? First of all, tell me how many years have passed from 74 to 79. 5 years. Very good. And it also says this keyword in here, increases by 41%. Also, in the beginning, in this 1974, it started with 5,000. Okay. So which one of these represents the growth, or how many transistors will be in 1979? Okay, first of all, it starts with the original number. You should start with 5,000. Okay, this is like P for principal. Okay, it's like the original amount. So if you take out a loan, it's your principal. All right, since it's an increase, we're going to be adding something to the whole. So we're going to be adding 0.41 because it's an increase. If it was a decrease, we would subtract. Okay, how many years did it happen? 5. Because this is an exponential expression, we're not going to say times 5. We're going to say to the 5th power. It's an exponent. Bingo. Right there. This is almost correct, except it doesn't have that little 1 right here. Right? This would mean it's actually shrinking because it's times 0.41. C? Yeah, C is saying 5,000 plus 1 point. No, that's wrong. We need to have this times like that. Okay. There we go. Last one. For each consecutive win, the Dragons have the number of tickets fans buy increases by a factor of 1.1. Whenever they use that phrase by a factor of, that's the thing that's going to go in your parentheses right there. So this is key. It's a little different than the last question I did. Whenever they use the phrase by a factor of, your factor is going to go right here. How many wins? 4. So it's increased 4 times. What did it start off as? 200, right? So we have our beginning amount, our principal right there. We have our factor, and we have however many times it happens. Okay? Which one of these is the same thing? Which one? So 1.1 to the 4th means take 1.1 and add it 4 times. What does 1.1 to the 4th mean? Right. 1.1 to the 4th means take 1.1 times itself 4 times. It's the same thing as that one. All right. I'll stop here, and I'll actually add one more assignment in there with some algebra. It'll be awesome. Okay.